Alright, let me give you some thoughts about 5.5 homework. This will be the first part of 5.5. I'll do 3 or 4 problems here for you to get you started. Let me start with number 13. In number 13, you're given a triangle that looks like this. Theta is over here. You've given these two sides. You calculate the hypotenuse, length of the hypotenuse using Pythagorean theorem, and you'll get the square root of 17. The question is, number 13, what's the tangent of 2 theta? You'll use your formula sheet. I mean, there's really two formulas you could use. Sine of 2 theta over the cosine 2 theta, or we can use 2 tangent theta over 1 minus tangent squared theta. I'm going to use that formula. And so it's 2 times the tangent. The tangent is the opposite over the adjacent, or a fourth, divided by 1 minus tangent squared, so that's a fourth squared. So I get 2 over 4 over 1 minus 1 over 16. So that's a half divided by 15 over 16. And that equals 16 over 30, which equals 8 over 15. And that's your answer for number 13. So that's how we use the double angle formula for tangent. 21. 21 is a little bit tricky. It's 4 sine x cosine x equals 1. They tell you we'll restrict it to 0 to 2 pi. Okay, so we look at this, and honestly, unless you've done this one before, it might be hard for you to see how we can rewrite this problem. Instead of 4 sine x cosine x equals 1, we can break the 4 up into 2 times 2. And when we break the 4 up into 2 times 2, we're left with this 2 sine x cosine x, which happens to be the double angle formula for sine. And so now that we rewrite it that way, we're left with the sine of 2x equals a half. And this is now like it was in the previous part of chapter 5. Where is the sine equal to a half? We know it's a pi over 6 angle. We're looking for positive a half, so it's pi over 6, which is first quadrant, 5 pi over 6, which is second quadrant. Now we do need to look at the plus 2 and pi piece, and I'll explain why in a minute. So we take these two answers and we set them equal to 2x. So we have 2x equals pi over 6 plus 2n pi. And when we divide by 2, we get x equals pi over 12 plus n pi. Okay, we have to divide by 2 both here and here. Okay, then we do the other angle, the second quadrant angle. When we divide by 2, we get x equals 5 pi over 12 plus n pi. Alright, now, remember we're restricted, x is restricted to be between 0 and 2 pi. Let's take this first answer, which is x equals pi over 12 plus n pi. Okay, when n equals 0, x equals pi over 12. When n equals 1, okay, it's pi over 12 plus pi, we get 13 pi over 12. This is still in the range of 0 to 2 pi. When n equals 2, we've now exceeded the upper limit of 2 pi. So there's two answers that are actually going to come out of this. One at pi over 12, one at 13 at pi over 12. We're going to do the same thing with 5 pi over 6 plus 2n pi. When n equals 0, we get 5 pi over 6. 5 pi over 12. You already did this, and I forgot to bring it down. It's right here. When n equals 0, we get 5 pi over 12. When n equals 1, we get 5 pi over 12 plus pi, which is 12 pi over 12, which makes 17 pi over 12. And then if we made n equals 2, we would exceed the 2 pi limit. So the two answers that come from the second solution are 5 pi over 12 and 17 pi over 12. The two answers that came from our first solution are pi over 12 and 13 pi over 12. All four of these are valid answers. Let me go ahead and show you number 29. In number 29, you're given 6 sine x cosine x. And the instruction in number 29 is to rewrite the expression using the double angle formula. Well, remember that the sine of 2x is 2 sine x cosine x. So let's rewrite 6 as 3 times 2 sine x cosine x. And when we do that, we get the final answer. Okay? Alright, and then lastly, let me do for you number 43. We did one of these in class with the sine. Now we'll do it with cosine. So in number 43, we're left with cosine to the 4th x. And the instruction is to use power reduction and express the terms as a sum, all the terms being of the first power. So if you remember what we did in class with sine, we'll rewrite this as cosine squared x, cosine squared x. We'll use the power reduction formula, and we're left with 1 plus cosine 2x over 2. That's for cosine squared x, and we just repeat it. Okay. Now, unfortunately, we have to FOIL this. So 1 plus cosine 2x times 1 plus cosine 2x is 1 plus 2 cosine 2x plus cosine squared 2x all over 4. Well, we still have the square here. So what we're going to do is we're going to use the cosine power reduction formula again on this piece. So we have 1 plus 2 cosine 2x plus, now I'm going to use the formula, 1 plus cosine 4x over 2. And it's 4x because, again, you got to look at the formula. The formula says take whatever is here and double it. Okay, we have 2x, so we need to turn 2x into 4x. If that doesn't make sense, I'll go over it with you next class, but you gotta, when you have a 2x here, to use the formula properly, that becomes a 4x. Now I'm going to create a common denominator here up in the numerator. I'm going to make everything divisible by 2, which means I have to multiply this term by 2 and this term by 2. So we get 2 plus 4 cosine 2x plus 1 plus cosine 4x all over 2 and all over 4. Okay, now I have 2 plus 1 is 3. So I can go 3 plus 4 cosine 2x plus cosine 4x. And when I divide by 4, which means I multiply by a fourth, the 2 gets multiplied by the 4, and I'm left with 8 in the denominator. And that's your answer. We've now taken cosine to the 4th x. We have no exponent greater than 1, and we have a sum of terms. So that would be your answer. We'll do more videos on 5.5, but this is to get you started. Good luck.